Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong, Red Hat Marketplace, and CircleCI. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of it or you'd just like to share it with a friend afterwards, the on-demand will be made available after the webinar concludes, and you should receive an email with a link to that recording. If you look to the right side of your screen, you'll notice a Q&A tab and a chat tab. We want you to use the Q&A tab to send in any questions that you have for us today, and we want you to use the chat tab for anything that you have that might further our conversation, or if you just want to tell us from where you're tuning in. Finally, at the conclusion of today's webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So on to our topic today. We're going to be discussing deploy ARM-based instances in CI/CD pipelines with CircleCI. And I'm joined today by Robert Shanafelt, Senior Solutions Engineer at CircleCI. Robert, huge honor to have you here with us. I'm going to go ahead and turn the floor over to you.
All right, thanks, Cody. Appreciate it. So welcome, everyone, to this webinar. I have to say, I'm filling in for Angel Rivera, who was unable to make it this week. He had some urgent things come up, so I hope I can fill his shoes, but I know he's quite the evangelist for CircleCI, so I'll do my best. Anyway, so here we are. We're ready to talk a little bit about ARM-based instances, and I'll start right off with the agenda. So we're going to talk about, just kind of do an intro to CI/CD for those who might not be fully familiar with it, and a little bit about CircleCI, just so you have kind of some context for what we do. Then we'll jump into talking about ARM and Graviton2 in the specific instance. And then finally, we'll basically start talking about how to use those ARM resources with CircleCI in your build pipelines. And then we'll wrap up with a few things at the end, and we'll be finished. I expect this to probably take about 30 minutes, plus or minus, kind of depends on how things go. So let's get started. So CircleCI, our mission is to give development teams the power to build and deliver software with speed and confidence. So we're a CI/CD, continuous integration, continuous deployment platform, and we help software teams build better software across those platforms and deliver it quickly while improving the developer experience. So our mission revolves around this mission, and this really hasn't varied in about the 10 years we've been in business, where we've been laser focused on helping development teams be more productive. So at a glance, CircleCI, we're the largest shared CI/CD platform. We have over 2 million daily pipelines on AWS alone. Overall, we have over 1 million active developers at 40,000 plus organizations. And we like to think that we're helping all these organizations build, test, and deploy software with speed and confidence. So where do we sit in the tool chain? So in typical development cycles, you have your creation phase, an orchestration phase, which is actually pulling together all those artifacts for your actual deliverable. And then finally, you have an operation stage for actually moving things into production. We sit right in the middle. So in the beginning, when you're creating your product, you're collaborating, you're writing source, and you're storing that in places like GitHub or Bitbucket. CircleCI is going to be sitting there monitoring those repositories, looking for updates, looking for your commits to then begin kicking off a pipeline. And from there, we can do builds, tests, we can package up artifacts, and then ultimately we can do a release. And those releases eventually go to something like Amazon Web Services or Google Cloud. So we like to think that we sit right there in the middle and we kind of help bring everything together and test it out, make sure that your product is right, and make sure it's ready to go to production. CircleCI is a developer's first company. We are about 70% faster than other players in the market, and developers like to choose us because we're the fastest cloud tool available. With our approach to CI/CD, you have many ways to improve your build performance, such as parallelizing jobs like tests, and so your team isn't waiting around for builds to finish. And you can see from this chart here that that we have quite the leg up on some of the competition, and so we're really proud of that because we focus on developers first. You can see that we have about a 63% reduction in build wait times. And that dramatically reduces developer costs. So we like to think of that as being about 242 times less expensive to invest in CI/CD than it is to pay for lost developer time. So speed isn't just important because it makes developers happy, it makes you more productive, and it translates to significant savings by reducing those developer costs. So if you compare, say, $87 an hour, the average developer hour, to 36 cents an hour to run CI/CD and let CircleCI handle that for you, you can see that's kind of a no-brainer in terms of how much it can save you in your organization. And just as a quick refresher of CI/CD, we think we offer the best-in-class continuous integration and continuous deployment platform. And a CI/CD process is basically, think of it as like a pipeline of things moving from, in this diagram, from left to right. On the left side, we have sources of change, such as your custom code, open source code, internal services, third-party services, registries, dependencies, etc. And then CircleCI looks at those sources of change, and when it finds those changes in those systems, or if you were to invoke CircleCI to begin processing, we will then do builds, tests, deploys. We can package up your artifacts, and then finally we can push it towards the end there, which is the release process, which eventually leads to your consumers of change, which is your end users or perhaps your internal services that you use. So at CircleCI, you can build pretty much anything you can imagine. We have support for a wide variety of platforms and systems. We have executors for Docker for every major OS, Linux, Mac OS, Windows, as well as pretty much every language and framework you might come across. Why is this important? Well, this gives your team tremendous flexibility to run anything you want without having to worry about provisioning those resources yourself. There are a massive number of Docker images just out in the wild. You can certainly use ours. We provide convenience images, which include extra utilities that are useful for build processes, but you're perfectly welcome to use your own or use public Docker images. And also we offer machine images. And these are lower level resources that provide you full access to the machine, including like the Docker system as well. In addition to Linux, Windows, Mac, in containers, we support multiple platforms such as x86 and ARM, which we're going to talk about today. And we also offer accelerated compute, such as CPU accelerated instances, as well as GPU accelerated instances. So integrations and extensibility. So CircleCI is highly flexible, and we have the ability to handle common tasks such as build, code analysis, tests, artifact generation, and notifications, and so on. But we also support workflows such as those shared by the community or used within your organization. You can also integrate your existing tool chain to stay productive using our API, CLI, our CircleCI webhooks, and orbs, which is a convenient way to encapsulate and extend CircleCI functionality. Speaking of orbs, let's take a little closer look at what's available to save you time. So when you look at the CircleCI ecosystem, we have a huge number of integrations, and these are integrated through what we call orbs. You can think of orbs as like a package manager for CI/CD tasks. It's simply a large chunk of configuration that's in a reusable package that you can import into your own configuration. It's nothing magical. There's no build process for it. It's just simple configuration. But that simplicity is great because it lets you import the pieces that you need for your particular build process, and also lets us simplify a lot of the code to interact with various systems so that you're not writing it all out yourself. So for example, we have partners who have created orbs for things such as testing and performance, code coverage, package registries, analytics, and release tools. We also provide a large number of certified and supported orbs from CircleCI. We have things like cloud providers such as AWS, Google Cloud, Azure, frameworks such as Docker, Kubernetes, and also common frameworks, things like Gradle, Node.js. We also offer our own certified orbs that provide communication with tools like Slack, etc. So finally, if these don't cover your bases, if you can't find a partner tool or one of our certified orbs as well to solve your problem, you can always write your own private orbs. This lets you reuse code and processes, lets you encapsulate your company workflows, or if you just want to create a new template for how you want to set up your projects, those orbs that you keep private can be a really useful tool to encapsulate your functionality for your team. So that's a quick look at CircleCI and some of the things that we offer. We'll get into some more details in a few minutes. Now let's take a look at ARM and Graviton2. So what is Graviton2? Well, it's custom AWS silicon with 64-bit ARM Neoverse cores. Has targeted optimizations for cloud-native workloads, and also lets you rapidly innovate, build, and iterate on behalf of customers. So let's take a look a little bit about the history of CircleCI and ARM. So you can see in 2018, AWS introduced the Graviton chips. In 2020, they introduced the next-gen Graviton2 processors, which were a huge leap in performance. The underlying technology, as I mentioned, is AWS custom-built ARM Neoverse 64-bit processors. It's a high-performance microarchitecture for the server market. It's really specifically geared just for cloud computing. And it allows developers to run cloud-native apps securely at scale with better price performance. So when it comes to CircleCI, we were the first managed service to offer CI/CD with ARM compute. And CircleCI ARM lets you build, test, and deploy apps for ARM without managing your own systems. And then finally, coupled with AWS, you have unlimited scaling. You're obviously using compute in the cloud, so as many resources as you need, you have them available for your build processes. So what makes ARM special? Well, AWS did a study, and they did the Spec CPU 2017 benchmark against an environment that they set up for testing the performance of their traditional M5 instance and compared it to their new Graviton2 instances. And what they found was that the Graviton2 instances had up to 44% higher price performance ratio per vCPU. So what this shows you is that for the same type of resource, same family of resource, you can actually get better performance for your dollar than you do with this traditional x86 architecture. So let's take a look at another example here. Load balancing with Nginx. So Nginx, as you may know, is a popular web server and load balancer. And for this case, they did a benchmark for the number of requests per minute, requests per second. And they used the open source load tester framework called Work. And so they basically generated a whole bunch of HTTPS requests to send through Nginx. And then they monitored to see like what kind of throughput they got. And they found that with the Graviton2 instances, they got 24% better performance just by using the ARM instance. So again, comparing apples to apples, it's essentially the same compute platform, but just different architecture. The ARM was able to perform a bit better. So let's talk about technical benefits. So why bother to use ARM? Well, there's a number of reasons. It can streamline your migration. So if you're looking to move to ARM and you want to have confidence that you know how your performs, this gives you an option using CircleCI to basically do some of your builds with ARM, with the ARM architecture. Also, if you're migrating to Graviton2 and you need to be able to validate that code over time, this easily add to your current build process to supplement your build. So you can see both have a comparison between, say, your x86 performance and your ARM performance. It also can reduce your switches. So within CircleCI, you can use a variety of components within the same pipeline. So this means you can mix and match ARM x86-based environments, lets you validate both simultaneously. And it basically gives you a risk-free way to begin building and testing for Graviton2 without making a huge investment or setting up your own compute in-house. And so for startups and open source projects, this is a great way to scale workloads faster, better price performance ratio, really important for startups. And for memory-intensive workloads, Graviton2 instances are quickly becoming a go-to choice for many open source projects. So to sum it up, overall with Graviton2 ARM instances, you're going to get a lower total cost of ownership. You have the highest performance for your instance family, and you have 100% better performance ratio. And obviously, we all want to get as much as we can out of each dollar we spend, so this is a considerable advantage to using ARM resources. So let's take a look at using ARM resources with CircleCI. So at CircleCI, no resource classes. And this is an example of our Docker executor. And you can see that within those executors, we have a variety of choices for your compute. We have everything from small, which is like a 1 vCPU, 2 gig of RAM, all the way up to 2x, which gives you 20 vCPUs and 40 gigs of RAM. Now, why is this useful? Well, you can see the little snippet below. That's actually a snippet from one of our workflows. And within that workflow, you can see that there are separate jobs within your workflow. The nice thing about CircleCI is that you can configure your compute, your resource classes, for each job. So in the case below that, we have the medium to the tests running in parallel, and a small instance set up for the parameterized command. Why is this useful? Well, this lets you use the right thing for the right job. So for example, you may have something that doesn't require resources, say code, something very, very simple. Use a small and give your credits for something more important. Get the job done with minimal. You may have other things that take tremendous amount of resources. Maybe it's Bazel builds or linting thousands of files. In that case, it may make a lot more sense to move up to a much higher instance resource class because you can get the work done faster. In the end, whether you do take a longer time with a smaller resource or a shorter time with a bigger resource, in the end, it pretty much comes out as a wash in terms of costs. So in order to keep your builds really quick, it makes sense to scale that up to a higher performance resource class to be able to get the job done faster. So coming around to ARM. So CircleCI now offers 2 ARM resource classes. We have ARM Medium and ARM Large. The Medium instance class is 2 vCPUs with 8 gigs of RAM. And this is available for basically all of our plans: free, performance, scale, and custom. And we have ARM Large, which gives you 4 vCPUs and 16 gigs of RAM. And that's available for our performance, scale, and custom plans. So configurations. Let's talk about how would you actually integrate this with your project. Well, for those of you who are familiar with CircleCI, you already know that we just use a simple YAML file to set up your pipelines, workflows, and jobs, as well as setting up things like caching, your context for security secrets, and obviously we talked about earlier, importing orbs to give you additional functionality. So this config YAML is where we do all of our configuration, where you set up your jobs and you set up the executors that you want to use. So to set this up to use ARM, you just make a small change in your YAML. So let's take a look first at a standard Linux configuration. So this is a very simple configuration. It's actually a fully valid configuration file. You can see on the top there we have jobs, and underneath jobs we have build medium and build large. And then at the very bottom, call your attention to the workflow. So we have one workflow, it's called build, and that workflow calls 2 different jobs: build medium, build large. Pretty straightforward. So in this case, we're setting up a machine executor. So this gives your application full access resources, full access to the Docker processes. And each resource class is a dedicated VM that's created specifically for this job. So in this case, if you take a closer look at one of the jobs, you'll see that it's a machine image, and the image in this case is Ubuntu, and the resource class is medium. And in the build large job, we look down and we see that it's essentially the same, but now we have a resource class large. This is just a larger instance type that you can use for your Linux configuration. That's pretty much it. As you can see that the actual, what's actually executed for this job is just trivial. It's like a hello world, but it gets the point across. This is basically setting up 2 instances, one at medium, one at large. So what do you think is required to get this set up for ARM? Is it going to be like a whole lot of rewriting your configuration, a whole lot of extra work? Well, not really. We switch over to ARM and you can see that there's almost negligible difference. If you blinked, you might not even have seen it. But all you have to do is you simply update your resource class key to use an ARM instance instead of a standard Linux instance. So if we look at resource class, we see it's ARM medium and ARM large for the large build. We support 64-bit operating system images. So in this case, the image did change because we're pointing in this case to an Ubuntu ARM image. And again, as before, it's a machine executor, so you have a dedicated VM specifically for your job. So really that's all that's changed. So you could have the most complex configuration for your build projects. All you really need to do is you change your resource class and your image to point to those ARM instance types. The other thing is that's interesting is, as I mentioned before, since you see that these machine types are, these resource classes are defined per job, you can imagine a scenario where you have lots of different jobs of things going on. Let's say you just want to add the ARM support. It's going to be as simple as creating a new, copying and pasting, create a new job, switch the resource class to an ARM type as opposed to just the standard x86. And now you're able to incorporate an ARM instance right into your build process with essentially not affecting any of the other parts of your build. So it's really flexible. It's a really easy way to get started with using ARM. So let's wrap up with a couple more points here. We'll look at a customer case study, culture biosciences. So we had an interview with Sachabad Khalsa. We're talking to him about culture biosciences, and they think of themselves as AWS for bioprocessing. They want to be able to make it easy to scale bioprocessing as easy as it is to scale code. So the challenge for them was they were previously building Docker images with virtualization, but that solution was no longer effective for them because they were seeing processing times in excess of 6 hours. So they decided to try the AWS CircleCI solution using ARM Compute and Graviton2. The results were, well, to put it simply, said save them headaches, and that was worth a lot. But ultimately ended up saving hours of developer time per week and tens of thousands of dollars a year. So basically this improved their developer experience, improved the product, and got them to market faster. And they said the process was painless. As you can see from before, it takes very little to reconfigure to use ARM instances. And ultimately, the final quote for them is if you need to build Docker containers for ARM in the cloud, then it's a flawless, seamless solution. So how do you get started? Well, you'll notice I put a few links in the chat window for everyone. There's a link to CircleCI. I also put a link to some tutorials. So if you go to CircleCI docs tutorials, you'll find that we have a huge number of tutorials and example projects. Have just about every major framework for every programming language and tool you can imagine. We don't actually have a lot of ARM specific things out there right now, but most of these projects will be pretty straightforward, as mentioned before, to switch over to ARM instances. But for a more specific example, I put another post, another link in the blog, sorry, in the chat window, referring to a blog post. So AWS partner resource got together with CircleCI this last fall, and we put together a really lengthy, this isn't the whole blog post, a very lengthy blog post about building, testing, and deploying containerized applications using Graviton2. And what's nice about this is it's kind of a nice walkthrough. They give you lots of example code, example configuration, and they show you how to basically set up and tear down your own ARM infrastructure using Graviton2. So check that blog post out. That's again in the chat window. Finally, let's talk about key benefits. So innovation and scale. CircleCI delivers first fully managed CI/CD using Graviton2. Obviously, with AWS by your side, it gives you unprecedented scale to your community of ARM developers. You have on-demand ARM compute. So again, you don't have to build your own machines, set up your own on-premises infrastructure. You've got it right there at your fingertips. And then finally, price-performance ratio. We have up to 40% better price-performance ratio. So for various workloads, you may find that it makes a lot more sense to run on ARM rather than 6 architecture. It gives you a multi-architecture solution. So this lets you either migrate, if you're making a migration from x86 to ARM, gives you a path for that. But also gives you, if you're building and deploying in multiple architectures, it's yet another architecture to add to your suite to let you test a bunch of different environments simultaneously. And then finally, it simplifies your decision making. So it lowers that barrier to entry for getting into ARM-based compute. It's a simple couple lines of configuration and you're off to the races. So it's a great way to get started with ARM and start being productive. So why don't you get started? You can hop on over to the marketplace at redhat.com. You'll see that we've got a product page for CircleCI, and that will get you started with the marketplace. And of course, you can visit our website at circleci.com, and we're happy to help you get started. So thank you very much.
Well, thank you so much, Robert. Real quick, a reminder to our audience that today's session was recorded. Following this webinar, you'll receive an email with a link to access the on-demand, and you can also find the on-demand living on the DevOps website. Just visit devops.com/webinars. Let's quickly announce our 4 $25 Amazon gift card winners. Our first one is John R. Our second winner is Brian V. Our third winner is Elvis M. And our fourth winner is Colin M. So congratulations to the 4 of you. Please keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. So real quick, Robert, I'm not seeing that we had any questions come in throughout today's program.
Okay.
But we're getting lots of thanks. So job well done.
Great. Thanks, everyone, for being here. We appreciate your time, and hopefully you'll visit CircleCI and see what we can do for you.
Excellent. So again, Robert, thank you so much for being here with us, for taking the time to put together this presentation, and for filling in, most importantly. So that was, we really appreciate you being here with us.
Well, thanks for having me.
Thank you. I'd like to thank Red Hat Marketplace and CircleCI for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us for the entirety of today's program. Please take a second to fill out our post-webinar survey, and we hope to see you again at a future TechStrong webinar. This is Cody J. Brown signing off.